Lesson 11, a new way to measure angles. Our aim today is let's create a new unit of measure related to circumference and arc length. All right, 11.1, a 1 unit radius. A circle has a radius of 1 unit. Find the length of the arc defined by each of these central angles. Give your answer in terms of pi. So if we're talking about arc length, that means we're going to be using our circumference formula, which is 2 times pi times r. Now, we're not talking about an entire circle circumference, so we're going to use our formula for length, arc length, which looks like L, and they use this as a circumference formula. It's part of it, but we don't want the whole circumference, we want a fraction of that circumference, and that is based on the central angle of the sector, that being theta, representing that central angle. So basically, it's just asking you to plug in R, 1 for R, 1 for the radius, and then each of these degree measures for theta. So the easy part would be really be to plug that 1 in for R. All right, because it's always going to be 1. So really it's 2 times pi times 1, which is just 2 pi. All right, so now for each of these, we are going to be multiplying 2 pi by some fraction. So for 180 degrees, that would be 180 over 360 times 2 pi. All right, and instead of having that complex fraction there, I'm going to plug it into my calculator. Hopefully, though, we know that this is just 1/2. So I'm having half of 2 pi, or just pi. All right, 45 degrees, same drill, 45 over 360 times 2 pi. And I'm going to go ahead and show really all of these fractions because they're very important fractions when it comes to circles. They come up a lot on the SAT and definitely the Regents as well, which you'll definitely take the SAT eventually. Who knows about the Regents? But that's 1/8. So it's really 2 pi over 8, I could also say. So 2 over 8 is really the fraction we're dealing with here, which is really just 1/4. So that'll be pi over 4. So it's really good to sort of get these sort of down to memory, what this fraction is going to be. And you notice that it sort of makes sense because if this is pi over 4, if I add 45 together 4 times, or just 45 times 4, I'm going to get 180. 180 is going to have an output here of pi. And when I add pi over 4 together 4 times, I also get 4 pi over 4, or just pi. So there's a correlation between the degrees here and the length, this output that we're getting, based on this circle with a radius of 1 unit. All right, next is 270. And that really, I'm just gonna do the math on my own. 270 over 360, and I put that in a calculator, is gonna be 3 over 4 times 2 pi. 3 times 2 pi is equal to 6 pi over 4. And then I can reduce that fraction. If I say I don't know how to do that, I can also put in my calculator 6 over 4. Convert that to a fraction is really 3 over 2. So 3 pi over 2. Hopefully this is looking a little bit familiar to 10.3, where we had to talk about ratios, right? We kept getting these ratios with pi involved. And you'll see that those ratios are very useful when we're talking about measuring circles. All right, 225. So actually 225, I believe, is a multiple of 45. So I imagine this is going to be some sort of eighths. All right, 5/8. And that's really equal to 10 pi over 8, or if I reduce the fraction to 5 pi over 4. And you'll notice that both 45 and 225 have a denominator of 4. And we have 5 pi in the numerator here and pi in the numerator here. Well, if I take 45 and I multiply that by 5, I get 225 degrees. So you see that this same scale works for the degrees and the number of pi we have, the amount of pi we have. All right, and lastly, 360. Well, that one's much easier. 360 over 360 is just 1, and 1 times anything is itself. So we'll get 2 pi here for 360. So start to notice some of these patterns here. It will be something you do want to commit to memory eventually when you're taking the SAT and other tests like that. All right, that's all for 11.1.